Okay. Hold on, hold on. This one?
This is now on the curve, yeah.
Okay.
Can you make it bright?
Okay. Try. Okay. Oh, sorry. Hmm? Tole. Kau remote soalnya. Kau baru ada lapang ada. Lain. Kau baru lapang ada.
Light is not sharp. It's not sharp, but I can. It's supposed to be bright. It's not bright yet. But we only have 2 minutes.
Sure.
If you can make it bright, fine. Otherwise, it's okay. Yeah, I think this.
Is better?
But does it change the color? I think yeah. Let's leave it there.
Okay. Okay then.
Yeah, that's fine. Leave it there. Thank you. Okay. Let me see if we can turn on the light in the middle. This room is very nice and cozy. Very warm. Okay, and the mic is you can control the volume, right? Okay. Okay, so we are going to start. Just give us a minute now. Okay. Hi, Phil. So for those of you who are standing in the back, I guess you have to stand because there are no more chairs. If you want, you can come here. I think that's not going to work because we are broadcasting it on the YouTube. If you make it too dim, nobody can see anything on the YouTube. So we need to bring the lights back up, please. Yeah, I think this is fine. Can you see? Okay, Cheryl, can you see the? Is it okay now? Because if it's too dark, nobody can see anything. Okay, so we are going to go ahead and start now. I'm sorry for the delay. I think this is the first presentation, because the proper welcome reception, I think they're going to do that in the other room. Okay, we did not know that it will be so popular session. People are standing in there in the back. Okay, so we are going to start now. Network State Awareness and Troubleshooting, and my name is Faraz Shamim. I'm from Cisco Systems, and I'm a senior technical leader over there. I've been with Cisco for almost 20 years. So for those of you who are standing, I'm really sorry we don't have enough chairs. Okay. There's supposed to be two speakers, myself and Amir Akhtar. I think he got lost somewhere. He couldn't make it. So I need to do his part as well. So we will go ahead and start now. So the agenda for this is we are going to go over the troubleshooting methodology and the packet forwarding review. And then two things we are going to talk about, which is basically the essence of the entire presentation. We are going to talk about how can you troubleshoot, how can you make your network aware from the control plane as well as the data plane. And then after that, we will tell you how can you utilize all this thing that we have learned in your actual network environment. So to keep it focused, so what is this session about? So this session is basically basic network troubleshooting, focusing on the fault detection and isolation. So for context, we will cover some basic methodologies and functional elements of the network behavior. Now this session is not about architecture of specific platform or data center technology or the routing technologies. We will not go into the detail of those. We also offer this session to Cisco Live conference. Have anybody went to Cisco Live? Nobody really? Anybody run Cisco network? Okay. You were surprising me for a minute. Okay. So we present this topic as a general audience. So that means if you have been in the networking industry, even if you have started like 2-3 years ago, you will be able to understand that. There's not too deep knowledge. We will just provide you, tools and how can you utilize those tools. So it's a 90-minute presentation, and we may finish early. We'll see. Different audience have a different things. So looking at the big picture, so starting from the bottom, so there's a user who's not happy because he cannot reach the server, and he opened up the case or whatnot. So the case went to the network operator, and he says, this user cannot access the server. What could be the issue here? And he started pinging the server, and he says, pings are fine. What is going on? Is it Monday? Because usually on Monday you have too many traffic, it's the beginning of the week. And says, no, it's not the network. I don't see any problem there. And then he go ahead and talk to the application operator and says, this guy cannot reach your application. What is the issue? And application guy starts troubleshooting, and he says, well, I can ping fine. It's not the application. And he says, well, no, I cannot ping it after a while, so it must be the internet. So as you can see, there are three different perspectives here. From the user perspective, from the network operator perspective, and from the application operator perspective. So it really depends, which view are you looking at the problem. The problem could be, if you go really in the deep, you can see there are problem happening on the different side of the network. So let's go deeper into this problem. Same issue. Now, after you unpeel, just like the onion, you start peeling the layer off. So after you peel one layer and then say, well, it's not just the server. There are multiple ways to get to the server. And if you can look in this picture, To get to the server, you can go through the enterprise network or you can go through the ISP. Can you please close the door so we don't have the disturbance? Thank you. So as you can see, we have multiple ways to reach the server. You don't know that user that is complaining, which path is it using. So multiple networks are involved, multiple applications, multiple layered service, and there is a misinformation and inconsistency. And where is the inconsistency? This user is complaining, but at the same time, there are other clients which has no issues. So you see, there's a guy and he's not happy. I was talking to my niece, she's in Toronto, and that's her picture right there. Her name is Aisha. So I was talking to my niece, and I was asking her that, hey, can you send me your picture of unhappy so I can use your picture in this presentation? And she thought I was joking. I said, no, I really want to use the actual picture of unhappy. And she didn't send me. So I said, okay, what I'm going to do, I'm going to use you as a happy client or a cool client, which has no issue. So there she is, and I gave her the YouTube link so she might be listening if she figure out the time right. So if you look at this problem, this is not it. So if you go one layer deeper, there are firewalls involved. There are load balancers. We have NAT going on. So as you can see, there are so many things that are happening inside this network that you cannot just solve the problem but just by looking at, hey, a client cannot access the server. So there are so many things that you have to be aware of. And this is basically to make yourself aware of your network. This room is so warm now, I'm literally sweating. I mean, I've been doing this for literally 18 years. So if I'm sweating, it's not because, there are so many people. I've spoken to many people before. The room is literally warm. And, for those of you who can feel it, they understand that. Okay, so we will talk about, when you want to make yourself aware of your network, what things you need to be looking at. So why is it important, and what is network awareness? So network awareness is basically the view of the network, that what is it doing and why is it doing it, and the monitoring of data and performance in comparison with what was happening before and what is happening now. So you want to make yourself aware of that, because awareness is very important. If you are aware of a network, you will be able to quickly detect the hardware failures. And in case of a software failure, you will be able to see the early warnings that something is about to break. And anything that can go wrong tomorrow, you will be able to determine that just because you are aware of your network. And it will give you the faster resolution because you are aware of the network, you will be able to solve the problem quicker. And also, there will be a greater confidence in network by users and the application operators. Because before they contact you and they say, well, this is the network guy, he knows his network inside out, so at least we know that it's not the network issue. So let's troubleshoot it from the application perspective. So we have to think like a network detective to solve the issue. So with all your knowledge about your network and the awareness about your network, when the failure happens, what you need to do? You need to find the problem, and then you are going to use the methodology. And in the methodology, you're going to solve the problem. So you're going to start with the suspects. What are the suspects here? Is it the firewall? Is it the load balancer? And is it multi-path links, or what is really going on? And once you find that suspect, then you're going to go through this specific question that, okay, is the link up, or is the aggregation working properly, or Is the routing protocol working properly? Basically, you are questioning the suspect that will help you solve the problem. And after you solve the problem, the most important piece is you want to improve the time that you solve the problem. You don't want that problem to happen again, because that will be important that how can you avoid the issues in future. So if you notice, we were using the troubleshooting methodology here for those of you who came early. The presentation was using a different format, so it was in a different color. And the microphone, I wasn't expecting this thing to hold for 90 minutes like this, but I have to. So, we were troubleshooting the microphones. Who would be the right person that would be the perfect fit for this kind of environment? Somebody who is aware of the surrounding, right? A person who knows the audio system. A person who knows that, okay, what kind of projection we have to do. That will be the person who will be the right fix. A right person who can help. So basically, if somebody is not aware of the surrounding, he's going to come in without knowing what to do and end up wasting a lot of time. So this morning I was awake at 4 a.m., not because of the alarm, but because my wife was trying to reach to me. I'm, by the way, from the Dallas, Texas, U.S., so my wife was trying to reach out to me because something happened in my house. So my father was taking a shower, and so actually, you know what? I need to time myself because I cannot take more time on this thing. So my father was taking a shower, and then a loud sound, came. Some kind of alarm went off. And they were really troubleshooting that thing for the last 3 hours. So, it happened at 1:30 a.m. local time here. And of course I was sleeping. And she tried to call my cell phone, but I had the connectivity problem, as well as, my phone was on silent. So I did not answer after 3 hours later. So they thought, now this is a relevant story. The reason I'm bringing it up because I told my wife that, hey, I'm going to discuss this thing because this is so relevant. So what happened that, they thought it was a smoke alarm. And then, my son, he went and, we have a 2-story house, so he went and he took out all the smoke alarm. And the noise is still going on, And they called fire department. The fire department came to my house, and believe me, they couldn't figure it out. And they said, well, we don't know. There's no fire. We know there's a alarm going on, but we cannot do anything. So a neighbor was trying to help, and then when they reached to me, when I called my wife, said, what's going on? She said, there's this noise coming, from the bathroom. And my father took the shower, and it happened after that. I said, are you aware that we have a water alarm in the bathroom? And she said, there is? I said, yes, there is. And, it has nothing to do with the smoke alarm. It's the water alarm that is going off. So she gave the phone to my son. I said, okay, go and look for that water alarm at the bottom of the floor. And he took it and said, yeah, this is it. That's the one that's making all the noise. So he took the water alarm, put it in the garage, and then they started figuring it out. And then I told my wife that, you know what? You are not aware of our house, that what is in the house and what kind of things we have. So if you are not aware of your surrounding, it will take literally 3 hours or more to solve a problem. And then I said, okay, we are going to use this slide to see, what can we do. So you have to be prepared with the knowledge of your surrounding, the knowledge of your network. What do you have in your network? Because if you're not aware of your network, it's going to take too much time to solve a problem. And once you have the knowledge, once you have the awareness, if something happens, then you can find the suspect. Okay, what's going on? Is it my network? Is it the link? Or what is really going on? So you go through this methodology, and then you question the suspect, is it this one, is it that one, or what is really going on? And after that, once you solve the problem, you try to improve on that time that took to solve the problem. And that's exactly what I did with my wife, and I said, okay, you know what? There are 4 water alarms in my house. 2 downstairs, 2 upstairs, okay? And then the smoke alarm, you could see it, but the water alarm is on the floor. So if there is a water, how many of you are aware of the water alarm? There is a water alarm. 1 person? Really? There is only 1 person in the room who knows about the water alarm? Okay, I think there is a reason for that, because in the United States, for those of you who have been there, the houses are made from the wood. So the problem is, when there is water which is going on the floor, it can destroy your floor. It can literally destroy your house. So you have to be aware that, if there is any water leakage, you want to detect it very quickly. So I put 2 alarms there because, we have like 2 in the attic which has the, they call it water heater or the geyser, that you call. So if there is a leakage, you want to detect it quickly. So that's why there is a water alarm. So there are 2 connectors in the bottom. So if the water passes through, it starts making noise. And then the smoke alarm that, I think, is there one here? I don't know. Yeah, there is one over there. So smoke alarm is common, but the water alarm is only for those countries which has houses made from the woods. Okay, so my timer didn't go off. It means it's going to go off in 10 seconds. So it means, I did not want to use more than 5 minutes on this story. So I'm awake since 4 a.m. and this is fine. It's not too much. There you go. And it turned out that there is a fee. How many of you have iPhone? Really? That's like 20%. How many of you have Android? Oh yeah, I'm in the Asia Pacific region. Okay, anyway. I have iPhone, but there's a feature in the iPhone, and probably Android has it too. There is a feature that you can press that says do not disturb, but if you want to receive a call from your favorites, then it will ring your phone. So I'm going to do that. So I told my wife to be aware of the situation, and I'm going to make sure, what can we do to avoid that? I told her, you could have called the hotel room, and they would have ring me, so I would be awake. So she said, it was not that emergency. So I said, okay, fine. Okay, so that's for the story. Now, for the remaining time, we will talk about the control plane and the data plane. So there's a whole thing going on in today's network. We call it SDN, like software-defined networking. What it does is basically it's separating the control plane with the data plane. Now, in the control plane, if you look at the information, it has like your routing table, what the routing table looks like, and what path you're going to take. But it's the actual data plane which goes through that path and experience the issues or experience that path traversal. So we have to troubleshoot the problem from both control plane perspective and data plane perspective, and you have to be aware where the problem is happening. Is it happening on the control plane, or is it happening on the data plane? So once you find that out, then there are different ways to solve each one of them. If you're dealing with the data plane, then you have to rely on the packet condition, because your control plane says, okay, to reach destination B, you go from C, and then you will reach your destination. But the issue is, until you really traverse that path, you will not see what is going on in the data plane. Because in the data plane, there will be things like packet condition. There may be a problem with some filtering. There may be interface congestion. You may be going through a different QoS class. There may be access list blocking it, fragmentation and whatnot. All these issues will be experienced once you go through the data plane. But in the control plane, you will say, okay, to exit out the door, there is a path. Now, once you start working and you find all these tables, I don't have enough space there, so yeah, there are some space, so I can try going there. So as you can see, once I'm traversing the path which was given to me by the control plane, then I will experience all these issues. So these are the data plane issue that the packets see once you start traversing the path. So you have to look at network as a system that independent decision happens at every level. So for example, if a packet has to go from point A to point B, and you need to be aware which path is it going to take. There are some things under your control, but there are some things that you cannot control. For example, if a packet goes from router 1 all the way to router 6, so these two hosts are trying to communicate with each other. Now what happens that you send the packet to the default gateway and router 1 sends the packet to router 2. And at that point right here, from here to on the back, these are under your control. So you control this part of the network. So once you send the packet outside this domain, nothing is under your control. So you don't know which path is it going to take. It entirely depends on the routing algorithm. So let's say if it takes that path at the bottom, the red one. So from router 2, it went to router 4, and then 5 and 6, and then reached the destination. But there has to be a bidirectional communication. So this is one way. And to come back, it came on 5. And then what happened? It took the other path. Why did it take the other path? Can anybody tell me? So I'm talking about from router 5, why did it go to router 3, not router 4? What is it? Asymmetric routing. That's a very good answer. And asymmetric routing happens, it's the reality. Because you can go from one path, you can come back on the other path. And what kind of issues you will run into in the asymmetric routing? That kind. Because on the way to the destination, everything was fine. But on the way back, there was a congestion in that link. But the control plane said, okay, you have two paths to take. You can take one path, and the router did take that path. But there is a problem with that path. Control plane wouldn't know about that path, that there is a congestion going on. The data plane will detect that there is a congestion, but it cannot do anything. And this is the reason, we are moving away from this control plane and data plane business. We are separating the control plane with the data plane now with the help of software-defined networking, SDN. How many of you are aware of SD-WAN? You know SD-WAN? Okay. How many of you are aware of SD-Access? Yeah, there was a Cisco-specific technology, so I was not expecting anybody would raise their hand. I would be surprised if you do. So again, the idea of behind SD-WAN and SD-Access is all using the software-defined networking to separate the control plane from the data plane to avoid this kind of problem, basically. So there's a congestion going on. Now, what if we are running a voice over IP here? So this guy is upset because it cannot hear, but the other guy is not upset. It must have happened to you, right? You are on the phone with someone, and you're saying, hello, yeah, I can hear you, and the other person says, I cannot hear, I don't know what you're saying, I cannot hear your voice, but you can clearly hear their voice. This is the issue that you are on the other side. You can hear their voice, and your voice is being blocked. Asymmetric routing. If you're not aware of the network, then of course, you need to know that, okay, there are some things under your control, and at least for the part that's under your control, you will be able to tell that, okay, which path am I traversing? And for the path beyond your control, of course, you cannot do anything. Now, you cannot stop change from happening. Changes in the network is a normal thing to do. I mean, you have to change. But so changes are normal, and some changes are interesting. For example, if you make some of the change, you could lose reachability, You could end up in suboptimal routing that you saw in the earlier case. And if there are too many changes happening in your network, then you will see that there is an instability happening in your network because there are too many changes. So if you start making too many changes, it's not advisable because then you're going to make your network unstable. So you have to do changes slowly. So the three things that we have to do to solve the network issues is we are going to do when did it happen, where did it happen, and what happened. So when we look at the control plane and the data plane perspective, these are the three W's we are going to be dealing with: when, where, and what. So let's start with the basic. I really wanted to, know how many of you have labeled your device, but I don't want to put you in the limelight, so that's fine. If you have not labeled your device, I'm just going to tell you, if you don't label your device properly, then you are going to run into the issues. Because you start looking at the physical device and you have no idea which device is doing what. It's going to waste too much time to start tracking that, okay, which device is connected to what. So after you label the device, things like your name of the device or configuration, serial number, you do know the serial number because when you call tech support, they are going to ask you the serial number. If you don't have it in one place, then it's going to waste time. These things are going to save your time. What about the cables? Do you need to label the cables as well? Oh, yes. Because you do need to know that gig 01, where is it going? Is it going to the other side, gig 10, whatever? So these are important things. If you don't have it labeled properly, again, it's going to waste a lot of time that you're supposed to be working on something productive. And you have to. There are tools that which checks the changes. There are changes happening in your network. You need to track it down. That what changes are happening, and you can use different tools for that. So first thing first, so you need to establish your topology baseline. You need to know your network, who is connected to what. Is it the layer 3 device? Is it layer 2 device? And there are some vendors that provide the layer 2 discovery protocol. For example, CDP from Cisco, and then Foundry has it, Nortel had one. So and LLD is basically a standard one. So you can use these protocols to find out, who is connected to what, and start making the topology. Or if you can view it, then I guess you can use the visual inspection as well to build your topology. The idea is that so you are aware of your network. Honestly speaking, I started in tech in 1997 in Cisco. Half of the problem would be resolved if you know the topology very well. So we used to literally spend 50% of our time just to understand what the network looked like, who is connected to what. And then customer will point out that, okay, this is the portion where I'm having a problem. And then you go back and look at the topology and say, well, okay, so it's connected through this device. Okay, then let me concentrate only on that part. So that story that I was telling you, that what happened this morning in my house. So my wife gave the phone to my son, and my son was literally, he couldn't explain me the problem. He said, there is an echo, and the alarm is coming, from the roof, So he pointed me in the wrong direction. You know what? And then I told him, okay, go back in the attic. There are 2 water alarms there. It must be coming from there. So he went in the attic, and then he says, no, it's not there. And then it says, then there's one in the bathroom. You missed that. So you need to go in the bathroom. He actually initially pointed me on the roof. He said, it's coming from the roof. Actually, as a matter of fact, it was coming from the floor. So he threw me, in a different direction. So that wasted, another 5 minutes. So, but if you are aware of your network, it will save time. So, so there are tools that will help you in creating your topology and keeping track of your inventory. Most of the NMS tools provide you this information, and there are tools like NetBrain, NetDisco, NetDot, and I will give you a small brief description at the end of the presentation. Now, next thing you need to do is you need to look at the logging. So there are two kinds of logging that we deal with. It's either the central logging, or you log it on a specific server, or you log it locally. So if you log it on a specific server, then you need to go through the logs. Maybe on a daily basis or the weekly basis, you need to find out, what's going on in your network, because all those logs that is printing, it's printing for a reason. It's not, the reason is not to overwhelm your server, but something is going on. That's why you have those logs. So these tools, like MookSoft or Syslog and Logstash, it will provide you a tool that you can go through all the logs and find out what are the important things I need to look for, and then make the decision based on that. If some change needs to happen, then you can do that. At least you should be aware of the local logging. If you cannot capture the log on the central server, then at least on the local level you should be able to find out what's going on. Now, because we are dealing with the control plane, so we have to be aware of the state of the routing. So what is happening at the routing protocol level? Now, so when you talk about the routing protocol, so you need to find out which routing protocol you're running. So in this case, we are running OSPF, and I know it's too small from the back. I don't think you can see that, but we are running OSPF here, okay? What is your next hop pointing to? So you take a look at your state of your network. So you look at, okay, what is the next hop pointing to? How long ago you have received this route? So in this picture, it says 13 minutes ago or 13 seconds ago. So it means, it just refreshed. So something made it refresh the route. So something just happened. So if you're troubleshooting, you look at all these details. Now, in case of running OSPF, you need to be aware of the other things that, what are your database looks like, and what are the things that you have in your network. So it doesn't really, it's not really asking you to be an expert in OSPF, but at least on the basic level, you should be able to tell what's going on in your network. So for example, again, it's a very small output, but I can tell you, so the number of LSAs that you have in your network, what are the number of external LSAs that you have in your network? External LSAs mean you are doing a redistribution. So if you're not doing a redistribution, for example, in this case, it says number of external LSA is 0. So that means there is no external redistribution. If this is a normal output, then you should be okay. But if you're not expecting any external network, then the number, anything other than 0 should be alarming, that somebody have done some redistribution. Number of areas in this router is 1. So it's only connected to the backbone area. So now if you're expecting other areas as well, then just by looking at that, if it says, well, it's only showing that you're only connected to one area. Number of interfaces in each area. SPF algorithm executed how many times? So here it shows SPF algorithm executed 4 times. Is that a problem? 4 times SPF algorithm. Do you think it's a problem? Is it? If it's your network, you're looking at this output and you saw that, okay, 4 times it has run the SPF algorithm. Is this normal? Should you be worrying about it? It ran 4 times, yeah. No, it ran the SPF algorithm 4 times. Is this something to be alarmed about? Would you ignore this? Of course, 4 times is not a problem. But if you come back after 15 minutes and it says 400, that is the issue, because it means it's constantly churning. There's something going on constantly in your network. So 4 is not an issue. Even if you bring up the network, at least it's going to run it 2 times. So if it's constantly happening, that if that number is literally large and if it's changing, that it means something is happening in your network constantly. Neighbor relationship. So when you're running OSPF, they form the neighbor relationship between the 2 routers. So these are the Cisco routers output. I think for those of you who came late, I mentioned that mostly it will be vendor neutral, but I said mostly. So this is the output from the Cisco router, but it's using a standard protocol. So that means, if you know OSPF, you would be able to tell how to troubleshoot OSPF, without any vendor labels. So you can troubleshoot Juniper network, you can troubleshoot Huawei, you can troubleshoot Cisco network easily because you are aware of a standard protocol. So here it says the state is full, so it will tell you the condition of the state, how many state changes it happened. So it says 6 state changes, which is kind of normal, but if it's like a very big number, then it means something is happening constantly. It gives you about the retransmission queue length and number of retransmission, and right now it says 0, so you don't have to worry about it. So that's for the OSPF. Now on the BGP, there's a thing called BGP monitoring protocol. How many of you are aware of this BGP monitoring protocol? Not a single hand. Okay, let me tell you what that is. So BGP monitoring protocol is basically, it's a standard, and they have just filed, they just put an RFC number to it. So basically before the BGP update comes to the router, it will send it to the collector. And the collector is going to see the raw BGP update before it applies to the router. So any kind of policy that is going to happen on the router, before that it catches that BGP update and see what are the conditions in the BGP. So the RFC, if you are interested, is the RFC 7854, which talks about the BGP monitoring protocol. And is basically, there is a client router which provides a pre-policy view of whatever you're receiving from the neighbor. And the update messages from the peer sent to the BMP receiver. So the example usage would be, if you want to do a traffic engineering, you want to see what kind of BGP path it has. So I will show you some example on the next few slides. So this is coming from the OMP, it's called OpenBMP, and it's a standard tool developed by Cisco engineers. There are 3 of them. If you're interested, you can go to the openbmp.org and download their tool. So basically, it gives you access to the actual BGP updates, and you can poll that update every 15 minutes and receive that information just to see what is going on for a specific prefixes. For example, a prefix, what is the peer ASN address? What is the peer next hop address? And looking at the specific prefix, is there any local preference set on the prefix? What about the MED value? What about the AS path length? Because I'm about to make a decision that I'm going to follow the other path, I'm going to prefer that path, but I want to see, is it taking a longer AS path? Is it even a valid decision or not? So before you do that, it will give you all that information, through the BMP. So it's a very powerful protocol, basically gives you the view of the actual BGP prefixes. Now let's talk about the data plane. And like I said again, in the control plane, we want to know the 3 Ws, when, where, and what. So same thing that you are going to use it for the data plane as well, when, where, and what. So looking at the data plane, so when we talk about the data plane, we have to look at from the user perspective. So you have to treat your network as if user is riding over that and what kind of issues they are going to run into. So you can do a synthetic service, for example, using the IP SLA that I'm going to show you in the next few slides. You can do a ping, you can do a trace, but when you do a ping, you have to keep in mind that not all the remotes will be able to respond to the ping. And when you do a data plane, you have to keep in mind that you will have a better coverage if you have more than one host to test from. So you can just not rely on the one host output. You have to be looking at the multiple IP addresses. And also you need to look at the uptime and the performance. So if you trying to look at the performance issue that user is experiencing, there may be a latency, there may be a jitter, packet loss, so you have to experience all that by running some synthetic checks. And you have to look for some pattern and changes, what really went down. Are some of the user up and some of the user are down? So for example, in the very early slide I show you there are some users which are happily going to the network, but then on the other hand there were some users that were complaining. And also you have to use this thing wisely, because if you are creating a synthetic traffic, of course it's going to use the network resources. So you cannot, use it blindly and just keep on testing it, because you have to realize it's a real network. Now IPSLA, there's an RFC 6812 which talks about the IPSLA. So it's used for the synthetic traffic measurement. And the things that can provide is basically you will be able to look at the network performance monitoring or the availability or the SLA monitoring. And then for the measurement metric, you can use it for the latency, packet loss, jitters, and the operations. You can use it for the jitter operation using UDP or TCP and etc. Now, you can use the existing router in the network to do the SLA responder and packets, sending back and forth. But there are customers that, they want to deploy a separate router. We call it a shadow router. So that router's job is to only send the traffic, and then receive the response, just to find out, what are the things going on in your network. So basically, you do a jitter operations, with a separate router. Trace routes. So trace route gives you an additional information besides the connectivity. So if you're trying to connect to a device and if it's not responding to the ping, then you want to do the trace route that, okay, which exact path is it taking? So you do a trace route, and there are different types of trace routes. So there is a Cisco and Linux version, and then there is the Linux GNU version, and then there is the Windows version. So it really depends which trace route are you doing. You may end up in a different result. And I will have some slide later on just to show you, what the trace looks like on a different, when you're using a different one. So for example, if you're using the Cisco trace route, the UDP destination port it increments per packet. So it starts with 33434, and then, it increments per packet. The source port, if you're using the Linux, then it randomizes the source port, and if you're using Cisco IOS, an increment per packet. And if you're using the GNU tool in the Linux, is the UDP destination port is incremented per TTL, not per packet. So you will see a difference in the output when I show it to you. And the source port is randomized, but is fixed per entire run. And in the Windows case, they only use the ICMP echo request. So if the ICMP is blocked in the network, then Windows trace is not useful. I don't know if you have experienced that or not, but you are kind of stuck. So these are some of the examples, and I know it's really difficult to tell from the back what is a trace route, but this is the Unix trace route. So you have done a trace from the source, and in this case it's from North Carolina to some destination in China. So you have sent the trace, and it took about 16 hops. Now, the one on the right side, if you guys can see it from the back, so these are telling you that, okay, you are sending 3 probes, and you're getting a response from 3 probes, and how much time is taking. So starting from 1 through 5, you're seeing AA, BB, CC. So you're receiving a response from the specific site. But if you look at the 6th hop, so 6th hop is saying FGF. So that means it's telling you that, okay, from the source to destination, you have 2 ways to get there. So if I want to go to the back of the room, I have a choice from here, this side, okay, and I can turn around and I can get from here as well, right? So that gives you 2 options. That's exactly what you're seeing in the trace route output. So it's saying that you have 2 ways to get there, which is perfectly normal. But if you look at path number 8 and 9, so these slides will be available later on, so you will be able to see what we are talking about. So if you look at from path 8 and 9, is being repeated. So I don't know if you have experienced that in reality or not, but if you are doing a trace route, and if you see a repetition, and you say, well, I just got a response from this host, why, or from this router, why am I seeing it again, on the next hop as well, I'm seeing it. And the reason you're seeing that, because you have a situation that, you can get to that destination from one path directly, and then you can get to the other side through another path. So basically, think of a triangle, okay? So first corner on the top, A on the left, B on the right? So going from A to the B, and then going from A to C and then B, okay? So these are your two paths. So the first path, you can get there directly, but on the second path, you can get there through C, and that's why you see the two repetition. So when you see the repetition, it means, there is a shortcut that is happening in the trace route. Now, what about, I know you cannot see it, but let me tell you what it says. You cannot see it, right? So 22 millisecond, and the next path, it says 140 millisecond. What do you think happened? It's a 120 millisecond increase. What do you think had happened? International link. See, I'm in North Carolina, I'm going to China. I have to cross the Atlantic Ocean, right? So the Atlantic Ocean is increasing 120 millisecond output. So that basically increases that, okay? Now, what is going on here? So the ... it means there is some kind of filtering happening. So basically, it's not responding to your trace route, which is fine. Normally, it does happen. And then at the end, there's another 100 millisecond added at the end. So what do you think? The packet came back? Why another 100 millisecond at the end? Now, these are the real issues, guys. If you're troubleshooting your network and if you see this output, you should be aware what's going on. Otherwise, it's going to take longer time to troubleshoot. So additionally, we will see that later on, the host that we are trying to reach, is very busy. It's very busy. It's replying back, very slowly. So that's why you have a 100 millisecond delay at the end. You're not coming back from the Atlantic again, but, it's just taking longer time. Now let's look at the GNU trace here. So we have used the GNU tool, which uses the per TTL. So here again, it's only going to show you once. So basically, you are seeing on 9 and 10 is being repeated. And as I told you, earlier, that if you see a repeat in the hops, that means, you are dealing with a shortcut there. So one path is directly reaching there, and the other path is staying in the longer path. So it just, is a different trace, which gives you a different output. So if you do a normal trace, if you can't really figure it out, then you can do a GNU trace and see, what's going on. There's another trace called LFT. How many of you have used LFT? Nobody. Good. Go ahead and use the LFT, when you go back. It's a good trace. Let me tell you what it does. LFT is a layer 4 trace. So basically, it dynamically adjusts to the response, and it gives you more information. For example, along the trace, it narrates back to you that what's going on in the network. So for example, it will tell you what is the AS number that you are traversing. It also tells you, the ISP name. So for example, Concert, which is BT, Quest here, RIPE is the European organization that uses for the internet registries. NCRAN is the North Carolina Research Education Network. So it gives you that information, and look at that. See that ... or a star? It says there is a firewall there. So basically, you're reaching the firewall, and it's telling you that there is a firewall there. So the next gateway may be statefully inspected packet. And then again, there is a asterisk, and it says neglected because we did not receive any reply. So even with the layer 4 trace, you may get some information, but you may not. MTR. How many of you have used MTR? Okay. Do you know what MTR stands for? The one that you have used, what is MTR? Anybody know what MTR stands for? Monitor? No. Matt? Did you say Matt? Okay, he knows. It's called Matt Trace because Matt Kimball was the guy who invented this thing, in 1997. But I have a news for you. It doesn't call Matt Trace anymore. It's called My Trace because, there's a person in 1998 who took over from Matt, and he called it My Trace now. So it's My Trace, and, it's an open tool. So it basically, it not only does the trace, but it also does the ping to the hops in the middle just to find out, the packet loss information. It's a very good tool, basically. So if you look at the output here, and again, you cannot see it very properly, but the first column, it gives you the loss. What are the packet loss? So you are seeing 0, 0, 0, and all of a sudden you see 1, and then you see 0, 0, 0. If this is the situation, there's nothing to be alarmed about because, it may be, just a one-time thing, just a noise, so you can ignore it. But if it's not sustained, then you don't have to worry about. But if you look at it starting from line 13, there is a 5% loss. 14, there's a 5% loss. 15 is a 5% loss. This is something that you should be worrying about. That there is a constant loss, a sustained loss from the 13th hop and onwards. So this is something that you have to worry about. And also, if you look at the last column, it says standard deviation. So it's basically looking at the standard deviation. And if you remember, in our previous trace, one of the hosts was replying very slowly. So basically, this is the case here that, it says that's why we have 80 because, that end system is really, really slow. But, if you compare, the trace sort output, MTR, is just giving you more information here. Let's look at the other information. For example, you need to be aware that the link that you're going through is up or not. It's a very basic thing, but sometimes you miss it. You're troubleshooting a network and your first link is down. So you check the interface status, is it showing up or not? And then if you look at the other information in the interface, like the MTU or the input queue, if there is any drops happening in the queue, or what is the input rate, all that information is very useful. How many of you are familiar with NetFlow? So NetFlow is, they have tried to define this thing in RFC 3954, but then later on, they've used a different RFC to standardize this thing. So NetFlow is a very great tool because it will be able to tell you what's happening, what kind of traffic you are seeing in your network. And believe me, you will be surprised because if you have not turned on NetFlow before, try turning it on, and then you will be able to see that what kind of traffic is riding on your network. And it will be really a surprise for you. And you can turn it on each device level and at the interface, certain interface, you can see what's going out and what's coming in. And you can specifically mention that, okay, from this specific source address to the destination address and specific application source port and destination port. So you specify what are the traffic that you're interested in, and it will display you the data. So NetFlow was developed in 1996 by Cisco engineers, and basically it's a de facto standard for acquiring the IP operational data. And they sat together in the ITF and they standardized this thing via IPFix. Do you guys know about IPFix? So IPFix is coming from the NetFlow. Basically, they standardized this thing via RFC 7011. So now it's basically standardized. So it provides a network and security monitoring, network planning, traffic analysis, and IP accounting. I mean, it's a very good tool if you want to plan what you want to do with the traffic in your network. It's not like but NetFlow is not a packet capture, by the way, because if you capture the packet, it will tell you every detail about the packet, source MAC address, destination MAC address, source IP, destination IP, source port, destination port, what kind of layer 4 information. What if you're not interested in all that? What if you want interested in, okay, specific IP, specific port number? So NetFlow is going to provide you, it's just like a phone bill, Who did you call, how many times did you call, and how long did you talk? So very specific detailed information. And packet capture is like a wiretap. So you're tapping the wire, it will tell you exactly all the packets that it's seeing. In the NetFlow, we have multiple examples. So we have flow-based, a flexible NetFlow. In the flexible NetFlow, you can monitor multiple monitors with a unique key field. So for example, you want to monitor a specific thing, specific keys, source and destination IP. And if you look at the other flow, it has the same source and destination IP, but over there you're tracking the SYN flag and interface, input interface. Here you're tracking, layer 3 protocol, input interface, and other stuff. So you can have a 2 separate flow monitoring going on if you're using the flexible NetFlow. Now, what about if you want to monitor that if the router dropped anything? There's a specific field, in the NetFlow that you can monitor. It's called forwarding status and drop count. So if you look at, it's an 8-bit field. The first 2 bits will tell you what is the forwarding status. It's 00011011. So 00 is unknown, 01 is forwarded, dropped is 10, and then consumed. So it will tell you that, okay, not only the router dropped the packet, but why did it drop it? Was it the W read, or was it the policer? Was it the bad TTL? What was the reason the router dropped the packet? So you can track that specifically. And also you can see, the drop count, that how many times it has dropped the packet, and what is that increment. So again, the RFC 7270 describes this thing. Now, if you get a hold of this slide, later on, there's a mistake there. On the status, the first 2 fields, it says, after the unknown, the forwarded, it says 10, and then dropped, it says 10. So that's wrong. The forwarded should be 101, and drop should be 10. And unfortunately, this is still showing in the Cisco website, which is wrong. And the actual value would be in RFC 7270. So if you happen to come across that, the RFC is more believable than the Cisco document. Now, what if the router doesn't drop the packet, but maybe a link drops? A link in between is dropping the packet. So you cannot figure this thing out if the link is dropping the packet, you cannot figure the things out. So that's where, the network performance monitor comes into the picture. So network nodes are available to discover, you can use it uses the RDP, TCP, and IPCBR. So when you're using the RTP, it uses the sequence number. Sequence number 1, 2, 3, 4. So every time you see a drop in the packet, there will be a sequence number that you're going to see the problem with. So RTP uses the sequence number, and then if there is a problem, let's say happen in the middle of the network. So let's say if they are using the network performance monitoring, something happened in the middle, then it's not going to give you that information about the node. So in that case, you will be able to tell that, okay, something is happening at the link level. You're going to see the packet loss, and you're going to experience the latency because of that. Now, there are some other options in the performance monitoring. For example, in the media monitoring, you can use RTV jitter, application response time. You can use, network delay and whatnot. So that's just there for the reference. Now, NetFlow QoS analysis. So you can use this thing in the live action, for example. How many of you know about live action or probably using it, live action? So it's a tool. It gives you the information about your network. What is the network riding? And basically, if you can see the protocol, the source address, it says even the source country, destination IP, destination port, and it will also give you the information about that which specific QoS queue then you are writing. So with the DHCP value of 46 or any other value, which class are you using? It will even tell you that. And then there is another tool which Cisco specific, Cisco Prime tool, which gives you that, okay, on a specific queue, how many % drop is happening. So it will give you the information about that. Let's move on to the packet analyzer. How many of you have used Wireshark? It's a very powerful tool, Basically, you are capturing the packet, but where do you capture the packet? That's the key here. So you capture the packet at the strategic location, where you think the problem is happening. So just before coming here, I was helping a government agency, and we were deploying SD access, and we were basically, we were expecting a DHCP packet with the option 43, which was not happening, and then we have to put the sniffer on the wire. And on the sniffer, we were seeing that DHCP is sending the request, but there is no option 43 in it. And we thought we configured that. Anybody know what option 43 is? It's basically, in the wireless connectivity, you have to tell the wireless LAN controller IP. So anyway, so we thought we put the option 43, but on the sniffer was showing that we are not seeing that a specific option in the DHCP request. So we went back to the DHCP configuration, and there we saw, it was Linux DHCP configuration, by the way. So there we saw that option 43 was in a different pool. The pool that we were interested in, it did not have option 43. It's basically a configuration mistake, and we had to put a sniffer on the wire to figure that out. So you have to put this sniffer strategically on the location where you think is going to give you more information. Now, if you cannot put a sniffer on the wire, then for those of you who are using a Cisco device, there is a tool called Monitor Capture. It's not a debug, but it's basically, it monitors the packet when it leaves out the box. You create a certain amount of buffer for that. So it goes into the buffer, and you capture that packet, and then you send it to the protocol analyzer. And if you want, you can see the output on the screen itself. This is a very powerful tool because it's better than a debug. Debug will overload your network, but this will not overload your network. This will basically maybe outrun your buffer, and that's about it. But you will be able to see the raw packet, and whatever you're trying to capture, you will be able to see that. So again, it's a very powerful tool here. Now, for the IPv6, so we have not talked about any specific thing with the IPv6, but Cisco has come up with this tool that we are trying to standardize this thing, and there is a draft at the bottom that we have sent it to the ITF. It's called in-band OAM for IPv6. Do you guys know what OAM is? Anybody know what OAM is? Let me help you. Operations. What is A? Administration. Management. Okay. So in-band operation administration management, and it's a complementary to out-band operation administration and management. By the way, do you guys know what APRICOT stands for? The conference that you are in. Who wants to tell? Asia Pacific. That's the easy part. Okay, Asia Pacific, and what else? Regional. Internet. For operation technology. Yeah. It's a very long name to remember, Okay. So in-band OAM for the IPv6. So have you guys used record route option in IPv4? Anybody use record route option? So basically, when you're pinging a device, you want to know, how many devices it has traversed in the middle. So when you receive a ping response, it doesn't tell you, what path it took. I mean, you could do a trace route, but there is a record route option in the ping. If you look at the ICMP, while you're pinging, it can detect, the path it took and what are the devices in the middle. So that's called record route option in the ICMP. And there was no such thing, and if you look at the RC2460 for the IPv6, it did not define the option to record the route. So we have come up with this in-band OEM requirement where we are using the IPv6 extension header to record the route. So basically it uses the record route option there. And if you look at what information it provides, we have a timestamp. We have a packet sequence number which detects the packet loss. There's a timestamp which tells you the one-way delay. There's a node and ingress and egress interface which for the path recording. And then if anybody interested, there is a IETF draft for that. It's called draft Brockner in-band OEM requirement. And here's just the odd one. I know you guys cannot see it from the back, but when you're doing a record route option in IPv6, it will tell you that each path is it taking and what is the IP for that. So from source and destination. Now when you know all that, so whatever we have discussed so far, the control plane, how to troubleshoot and what to look for, and the data plane, what to troubleshoot and look for. Now, how do you put this thing all together? So basically, how do you prepare yourself? So basically, you enable the passive monitoring, and we have discussed several ways, in the presentation, and you enable the active test. And then in the help desk, you put the interview script that, okay, have you done this? Have you done that? And did you do this? All the stepping that you can put and maintain the checklist. And you need to provide the multiple group access to the tools. So if you're using a tool, you need to make it aware, throughout your network. And don't just keep it to the network's operators. Give it to the application guys as well. If you run into this issue, go ahead and use the tool and see, if you can figure things out by your own. And then there's a drill that runs in the firefighters. So you should be able to do that too. I mean, do not bring down the network, but just say that what if something happens? How are we going to solve the issue? So basically, the communication among the team is very important. So basically, there has to be a cross-domain team. There has to be a cross-domain alias or emails and whatnot. There used to be a red phone between Moscow and Washington, D.C. in the Cold War. I mean, the communication is still there, by the way. So in 1963, they came up with this conference in Geneva, Switzerland, that, we are nuclear power, we have to have some kind of communication between us. Immediate communication, So they used to have a hotline between Moscow and Washington, D.C. If something happened, you can pick up the phone and directly communicate. It wasn't, by the way, it wasn't a red phone. I mean, it was a way of communication, but there was no red phone involved. But basically, there was a communication that if something happens, we need to communicate immediately. So you need to develop something like that, and if something happens, you should be able to communicate with all groups in your network domain, because you want to try to troubleshoot it from all the aspects, not just one aspect. It may not be just a network issue. Now, so today, we have discussed several things, but, these are some of the things that, I'm going to show you a very brief description in the next few slides, and, what can you use it for. So, for the network topology and IP addressing management, you can use NetDown and guest-to-IP. Now, you can use any tool. I mean, it really doesn't matter. These are something that, we are aware of, that we have seen it working. But if you have a different tool that does this, network topology and IP address management, then feel free to use it. But the bottom line is, there has to be something that you should be using. For performance tests, if you want to test the performance of the link, you can use the iPerf3, and there's a NetPerf as well. There's another tool. For the service check, we have Nagios Score, Xenos Score, For the net flow log analysis monitoring, we have Logstash, Fluentd, and Splunk. And I've given you lots of examples of the trace route that you can use. The template-driven config, you can use Ansible. And if you guys are interested in the control plane troubleshooting, I've written a book. It's called Troubleshooting IP Routing Protocols. How many of you can speak Chinese? This book was translated in Chinese. That I don't even know, what they translate. So I should have brought the book, showed it to you. You could have told me, okay, this is what it says, because I don't know what they translated, because I wrote it in English. They translated this thing in the Chinese. So there is a Chinese version available. I don't know if you can find that. But that's a long, we discussed different protocol, OSPF, BGP, multicasting, and all that. So I don't know if you can find this thing here, but it's a good book, if you want to troubleshoot it from the control and plane perspective. Now, looking at the documentation, so NetDot, which stands for Network Documentation Tool. So that's an open source, started in 2002, and basically it discovers the network using the SNMP. The discovery happens for the layer 2 and layer 3 devices, and it dynamically draws a diagram and a topology of your network. And also the management of IPv4 and IPv6 address via IPAM. So this is what it looks like. I'm pretty sure you won't be able to see it clearly, but basically you can go and explore them. Guest2IP is also a web-based IP management software, and it supports a concurrent user. So basically, if there are multiple users that want to use it, then it supports that also. For those of you who are in love with the spreadsheet, who likes to track everything to the spreadsheet, you will like this tool, because it uses the spreadsheet, because there is a chance that you can make a mistake while you were creating the spreadsheet, but in this one the chances are low, because it's just running by the software. And it gives you a migration assistant from the managed IPv4 to IPv6 via this tool. And that's what it looks like. So you can see, the first column is the network, the mask, the description, and what is the site. So I think we were talking about earlier, when you name your convention, you have to have some kind of convention. So there are different conventions that are being used. It's a 3-letter city code or the state code or the country code, whichever makes sense. But the bottom line is it has to be identifiable, with that code. The iPerf3, again, is used for the active measurement tool for discovering, the available path capacity. And the test can be done in either direction. So if I'm the source and then there is a destination, I can easily run from the source to destination, right? What about the other direction? Remember the problem that I showed you earlier, that you can have a voice over IP and it's only one direction you can listen to the voice, but the other direction is failing. So how can you tell that there's a problem happening in the other direction? It's tool like this, iPerf will able to tell, So in the TCP, you can use it for TCP, SCTP, and UDP. So basically from sender, you send the packets to the receiver. So I have some output here, and again, it's a very small one, but it uses BWCTL. How many of you are familiar with BWCTL? Really? Nobody uses it? What does it stand for, at least? So let me solve half of it. Bandwidth. Bandwidth what? CTL control, right? It's a bandwidth test controller. Bandwidth test controller. And it's a very powerful tool. I think you can download that and you will be able to do the BWCTL for ping, for trace route. By default, it supports iPerf. So what you're seeing there, that's a default one that supports iPerf. So it runs for 30 seconds. So basically, you can define, how long do you want it to run for. So run for 30 seconds, throw away the first 4 seconds. And -C option, you're seeing from client to server, and then you give the server IP and the port number. So from client to server. The one on the right side, that is in a different direction. So you were saying -S, and then you're defining the source So basically test it and start it from the other side towards me. See, that's really difficult. I mean, it's difficult to think, how can you start something from the, but that's what this tool does, You start the test from the other side towards you, and you want to find out, okay, what is the bandwidth and capacity. So here, so from source to the destination, it's taking about 16 or 17 megs of bandwidth. But from the other direction, it's taking 942 megabits. So you have a smaller capacity from your side towards the destination, and a larger capacity in the opposite direction. So things like these, if you are aware of that, you can design your network properly. Then you know that, okay, what links are we dealing with? What capacity do we have on the link? And then, you'll be in a much better shape. iPerf supports NAT as well, but it has to be a static NAT. If it's a dynamic NAT, then iPerf will not work. Then there's something else called NetPerf. These are all standard tools, by the way. I mean, it's not Cisco specific, but these are all standard tools we are talking about. So NetPerf is basically, it works like iPerf, and it's a bi-directional, works in the NAT environment. So it gives you, the capacity, and it gives you a confidence interval as well, from the capacity perspective. How many of you know what's a confidence interval? It's a pure mathematical term. Do you know what the confidence interval is? Let's not go in there. So basically, it says 95% confident that, okay, this is the bandwidth that the specific link is using. So it uses the 95% confidence interval in this one. Then we have the other tool, Nagios Core, for monitoring and alerting engine. And it's an open source and using the C language, and it's flexible and scalable architecture. It helps you with the event scheduling, event processor, and alert manager. And you can use API to extend the capabilities to perform additional tasks if you want to. And it's designed for the Unix and Linux system. And again, it just, I just put a capture, what it looks like, what it feels like, but I don't think you will be able to look at more information just by looking at it. Xenos Core is also used for the network management system, and it's an, again, open source tool. It's written in 90% Python. How many of you are aware of Python? How many uses Python? Good. You will like this tool because 90% is written in Python and 10% Java. And it's a GNU-based licensing. It's a web-based interface for monitoring. A lot of government sectors in the U.S. and retail, finance institution, they use that, and the service provider as well. And again, that's just what it looks like. Logstash, again, it's an open source tool for managing events and log. There's a data log collection, filter, and it can just filter and display the logs according to your specification. We have a scalable data processing in there. It gives you analysis, archiving, monitoring, and the alerting mechanism through this tool. There is a web-based browser, called Kibana that was developed to view the Logstash data. So you can use Kibana to view that information. Then we have FluentD. It's an open source data collector written in C and Ruby, and it requires a very little system resource. And it's basically a simple and flexible and extensible tool. There are about 5,000 companies. So if you go on the website, it says there are 5,000 companies that are using FluentD for the data collections, or for more than 5,000. And it provides a unified logging layer and decouples data sources from the back-end systems. And then we also have Ansible, which automates software provisioning and configuration management, and it uses for the application deployment, migration, reduced complexity and repetition, and it comes from the Fedora distribution and Linux. So it basically, you can use it for Linux, Unix, and Windows as well. Again, this is written in Python and PowerShell, and you can also use it for the cloud environment. If you have a cloud connectivity to AWS or Azure. And Splunk is another tool. It's accessible via standard browser and mobile app. So I think they made the mobile app that you can use to look at all the data. It collects and indexes the data. It's a very powerful statistical search of the data. So you can collect the data, but you have to be able to search the data properly also. Then it will make sense that what are you doing with the data. So it correlates and investigates between events and activity. It displays a report in a customized dashboard. So they have like a specific dashboard, and you will be able to customize that also to see certain information. It turns search into real-time alert, notifies by email and RSS. So again, that's what it looks like. And then finally, we have a tool for the alerting and collaboration. So remember, when I was talking about to be aware of your network, so not only you want to make yourself aware, but the relevant party. So if something goes on in your network, who are the responsible people that should be aware, that should be made aware that, okay, something has happened in your network. So which team to alert on, and who is on the pager duty, all this information, you have to put that in some kind of tool that will basically reach out to that person via email or via instant messaging or whatnot, and basically contact that person. So pager duty and open duty is another tool that you can use for that information. And basically, once you find out that there is a problem in your network, then of course then you would need some ticketing tool as well to open up the case and then basically track the case. So for the ticketing tool, we have OTRS, Jira, ServiceNow, and MoveSoft. So these are the different tools. So again, at the end, just wanted to emphasize that to be aware of your network is the main thing that you should be focusing on. If you are aware of your network, half of the problem will be resolved because you know what is running in your network, compared to someone that walks in from outside and try to troubleshoot it with you. He's going to spend more time. He will take more time. But if you are aware of your own network, you can pinpoint exactly where the problem is happening. For example, if something goes wrong in your car, if you just take your car to the mechanic and say, okay, I don't know, it's not running, so figure it out. I mean, he can fool you. He can just give you lots of things. He can lie to you. He can do whatever he wants to because he knows what he's dealing with, but you have no idea. You are not aware of what's going on. My car broke down a month ago. There was a problem with the alternator. So I took it to the shop. I said, okay, go ahead and fix the alternator and tell me how much it's going to cost. I did not give him any option. He said, this is the problem. Go ahead and fix it. Tell me how much it's going to cost, and he just fixed it. Instead of, I just parked my car and said, okay, my car is not running. If I try to start it, it won't start. And he could tell me anything he wants to. And it could be alternator, it could be engine, and he can make it so worse. But if I'm aware of my own network, if I'm aware that what's going on in my network, I can easily troubleshoot it, and I can take half of the time that would normally take for anybody to solve the problem. So that was the whole idea behind this presentation, is to make you guys aware that you should be aware of your network, so you will be able to solve the problem much quicker and faster. And that's what I have, and thank you very much for attending. Okay.